One more section. I'm recording 1.3 and 1.4. The same day I try to post these for you, 2 a day, or 2 on the days we have class. So 1.4 covers, I know the title is vacation expenses because all the problems talk about vacation. But the math that they're covering is z-scores and percentiles. Okay. Also, it does cover a normal bell curve. Okay. Now, when we compare data, raw data isn't very helpful, like 5'6", 5'7", or vacation expenses, 100, 120. What is really, really important or makes data more comparable is if we convert things into percents. Then data is much more, I'm not even in here, much more comparable. Okay, so z-scores and percentiles convert raw data is just the numbers they were given, into percentiles. So here's the formula for z-score. So a z-score is your standard score. It measures raw data in terms of 2 pieces of information that we've covered. In terms of your standard deviation, which I abbreviate SD. Whoops. And the mean. Now, the mean has 2 symbols. So really quick, the mean has the symbol X with a line above it. And then they teach us a new Greek symbol. It looks like a U with uncontrollable tails. So both of those symbols are for mean. So here is the formula for z-score. It's the piece of data minus the mean divided by your, standard deviation. So that is the formula in the book. So I'm just going to go over this is your value. This here is the mean. And this here is your standard deviation. Now, in order to do a z-score, you might want to take a Post-it. The complete list of z-scores is in the back of the book. We're going to be using Appendix A, which in my teacher version of the book is page 718 for a complete list of z-scores. So you might want to mark that page in the book. And I'll have to get my book. We will be using this table to complete. Let me make sure I look at what page it is in your book. So Appendix A for you guys is the same page, page 718. It is a crazy looking, it's very large. Okay, that's what it looks like in your book. So for all of these, I'm going to have us round to the nearest hundredth. So for these problems, we're going to be rounding to the, I should put the round to the nearest hundredth. Now, in case you forgot, that's the second place. It goes tenths, hundredths. Okay? So let's jump right in and solve some problems together. So I'm going to try to use shorthand. A travel agency found the following data for families who go on a summer vacation. So a travel agency found the average family spends $1,900 on a summer vacation. Now, I have no idea how many days that represents or location, okay? And it has a standard deviation. So I'm going to put normally. That's what they say each time, normally distributed. So this is a normal bell curve, meaning there are some people near the average, some people way below, some people way above. Normally distributed with a standard deviation of $390. So part A, what is the z-score of a vacation costing $1,200? Now, something I should have said before, and I can still put it up here. Z-scores, let's see how I can fit this in up here. Z-scores no, sorry. I should have put this up here and I left it out. Scores above mean are going to have a positive z-score. I should put data. Thankfully, I have an erasable pen. Data below the mean is going to have a negative z-score. Okay, so in this case where I'm telling you, what's the z-score of a vacation costing $1,200? $1,200 is less than the mean, so I'm going to end up with a negative z-score. So just to go over how to use the formula, my z-score, I'm just going to put z, is going to equal my data minus the mean divided by my standard deviation. So here is my value or my data. So 1,200 minus the average, which was 1,900, divided by the standard deviation, which was 390. So here's my average, standard deviation, value. So those are the three numbers that I used in this formula. From here, it's a simple calculation in our calculator. Make sure you do the top first. So 1,200 minus 1,900 is negative 700 divided by 390, and I got negative 1.7948. Now I need to round to the nearest hundredth. 4 keeps it. So my z-score is negative 1.79. Now, the next few questions are how to use that z-score, how to use that data. So here we go. If I want to now talk about percents of families, so what is the percent of families? Well, here, I'll use the same z-score we used above. So what percent of families spent less than $1,200? Okay, so we have to look up our z-score. So we're going to take our z-score from above, which was negative 1.79. Now, the value on the left is the left-hand side of your table. The value on the right is the top columns of your table. So, turn to page 718. It's going to be hard to do without you here. So, whoops, I broke that up incorrectly. the first two numbers are on the left side. The hundredth spot is the top columns. Sorry about that. So on the left, I'm looking for negative 1.7. Okay, there's negative 1.7. Now, 9 is in the hundredths place. So the top, you can't see that here. The top part of my table is the hundredths place. So I'm going to have to scan all the way over to 9 because my number is negative 1.79. And I'm going to find the box where these two pieces of data match. And here it is. I don't know if, let me try to zoom in. 0.0367. That is where, if I look to the left, negative 1.7. If I look above, is 0.09. So I'm going to write that value down. And I get 0.0367 from Appendix A. Now, I'm going to turn that into a percent. So I'm going to convert to a percent. So this represents, I'm going to round this to the nearest percent. So this would be 3.7%. We can keep it like that. So 3.7%. So 3.7% of families spent less than $1,200. Now if I asked you the reverse, because your homework will ask you both, what percent of families spent more than $1,200? I would take that percent from above and I would subtract that from 100. And that would tell me everybody that spent above $1,200. So if I'm looking for less than a certain value, it's the percent or the value I get from the table. If I'm looking at percent of families who spent more than that, I take that number from my table and I subtract it from 100, right? Because that should be the greatest percent we can get. So if I do that, 100 minus 3.7 tells us that 96.3% of people spent more than that. Okay? Now let's try this again really quickly. What percent of families spent less than $2,000 on vacation? Okay? We could go higher than, let's go higher. Who spent less than $2,500? Let's just use a new value. So what percent of families spent less than $2,500 on their summer vacation? So let's start over. We're first going to find their z-score. So 2,500 is my piece of data, minus the mean, which I told you earlier. I'll scan up. The mean, or the average, was 1,900. My standard deviation is 390, so I'm going to divide by 390. So 2,500 minus 1,900 divided by 390, and I got 1.538. So I'm going to use 1.54 because that's the nearest hundredth. So let's review the first two numbers, and notice this is positive because this value is greater than my mean. So remember, 1.5 is going to be on the left. The 0.4 is going to be at the top. Okay? So grabbing our table from page 718, notice the page on page 719 is all the positive z-scores. So I'm going to go down to 1.5. There's 1.5, and I'm going to go over to 0.4. There it is. So notice 0.4 is above me, 0.04, and on the side is 1.5. So I'm looking at this square here, which is 0.93, 0.9382. So I'm going to round it just to the nearest percent. 94% of people spent less than $2,500. So that pretty much sums up what we're going to do today. I am going to practice another problem with you, just some other calculations that you might need. Okay, so here we go. Which one should I do? Oh, you know what? I'm going to do one other additional part to that problem. I forgot about this part. How to work backwards. So find the cost of a vacation in the 60th percentile. Okay, so if I wanted to know what did someone spend if they would have been in the 60th percentile, meaning 60% of people spent less than what they did. So I'm going to set this up backwards. They're telling me that 60th, if I convert that, would be 0.60 on z-score chart. So I know what my answer is. I know that my z-score is 0.60. I can just leave it at 0.6. What I don't know is the amount spent minus, I know the mean, divided by the standard deviation. So I know what my z-score is. I know the mean and standard. They want to know how much a family spent, the data. So I'm going to cross multiply. So 0.6 times 390 equals x minus 1900. So I cross multiplied. So 0.6 times 390, I got 234 equals x minus 1900. So to solve, I would add 1900, and x equals $2,134. So a family who spent that on vacation would be in the 60th percentile. All right, so let us now do another problem which covers a little bit more material and will prepare you for other types of problems. So number 2, remember all of this is on vacation. So a family of 4, that would be 2 adults, 2 kids, on vacation in this is for the United States, will pay an average of $247 per day for food and lodging. So that could be a hotel, that could be a hostel, that could be a campground, that could be a suite, condo, lodging, basically just wherever they stayed. Okay, and there is the standard deviation, or theta x, equals $60 a day, meaning that the average family is about $60 away from the average. Okay, so here we go. Let's say, what percent spent less than $307 a day on food and lodging? So when they're asking for percentile or percent, remember we have to find our z-score first, then we go to the table, and then we convert that to a decimal. So first I have to find the z-score. So my z-score will equal our data minus our average divided by the standard deviation. So using your calculator, 307 minus 247 divided by 60, I got 1. Now I'm going to make that in so that it has a decimal. That would be 1.00. So go to your table. Right on page 718, 719. And this one's nice because we just have simply 1.0. And there's nothing after the decimal, 0.00. So I'm going to use 0.8413. You can already say it from our table. I got a z-score of 0.8413. So 84% of families spent less than $307 a day. Beautiful, right? All right, next. If a family had a z-score of 2.1, what were their daily expenses? What were their daily expenses? Okay, so let's remember, if I know the z-score but I'm missing the data. So I know my z-score was 2.1. I don't know how much they spent, but the rest of the formula is minus the mean divided by my standard deviation. And I'm always using that information. I'm always using the average, the standard deviation, and our data. So I don't know if you remember what I did in the last one. I cross-multiplied, so I'm multiplying diagonally. So 60 times 2.1 equals x minus 247. 60 times 2.1, I got 126 equals x minus 247. If you add 247 to both sides, I got x equals $373. So a family with a z-score of 2.1 spent $373 on food and lodging. You know, they definitely didn't go to the grocery store. They just ate out at restaurants with that price. All right, so what is the variance for this problem? I know that my standard deviation is 60. So I know that standard deviation equals the square root of variance. So I don't know if you remember, I wrote it on the last section how I work backwards. So if I know that 60 equals the square root of my variance, then I've got to work backwards. And so to work backwards, I would square both sides, and variance would equal 60 squared, and 60 squared is 3,600. So how you work backwards, you simply square it. All right, last part, super, super important because you will have one like this. What percent of families spent between, really important, $200 and $275 a day? So how do I do a problem that's asking me for the percent between two different numbers? So if you get a problem like this, which I know you will because I looked at your homework, you have to find the z-score of each. So I have to find z-score of each one, and then we'll subtract to find the amount in between. So let's first start with the value on the left, 200. So what is my z-score for 200 minus the average divided by the standard deviation? And then I'm also going to find the z-score of $275 minus the average divided by the standard deviation. So I'm going to use my calculator to find those values. So 200 minus 247 divided by 60, I got negative 0.78. Okay, 275 minus 247 divided by 60, I got 0.47. And now I have to look both of these up in the table. So I'm going to look up negative 0.78. Remember, the negative numbers were on the left. So all the way down to negative 0.7, right? And over to 8, I got 0.2177. Remember, these two values are on the left. This value is on the top of the table, okay? For 0.47, that I would look on the page 719, 0.4, and scan all the way over to 0.7, and I got 0.6808. And so to know what percent of families are in between, I'm going to, sorry that this is at the bottom, I'm going to subtract. So 0.6808 minus 0.2177, and that gave me 0.4631. So I'm going to round it to the nearest percent, so 46% of families. And that concludes that problem. And that pretty much concludes that section. That is each type of problem I think you're going to see in this homework. Bye.